Hi there, I'd like to talk about the total derivative of velocity that you get in fluid dynamics. The total derivative is written with a capital D. It's the rate of change of velocity with time. Now if you imagine a river, some parts of the river are fast, some parts are slow, so you have a convective derivative. It matters where you are along the river what the speed is. But you also have a local derivative because the whole river could be getting faster. So it's equal to the local derivative plus the convective derivative. This is the speed dotted with the gradient, and the speed in this case is a vector. It's got an x direction, a y direction and a z direction. This bit here, the local derivative, that's quite easy because u is a vector and it's just the rate of change with respect to time. So that would be the rate of change with respect to time in the x direction in the I component plus the rate of change in the y direction, the j component, plus the rate of change in the z direction, the k component, and that would be that bit. And then you've got this bit. This bit is the speed dotted with the gradient. So if you imagine the speed in the x direction, ux, dotted with the gradient in the x direction, partial by x, of this whole, operating on this whole u thing. So that would be uxi plus u in the y direction j plus u in the z direction k. And then you've also got u in the y direction, the gradient in the y direction, and you've got u again, because this whole operator is operating on u. There's the ux gradient x operating on u, and then the uy gradient y operating on u. Just write that in. And uz. So these are the two parts. You can see that there's I components, j components and k components, and you're going to want to separate those out. So do that. We'll have the I component, writing down all the I bits. Right. And the I bit from here, ux, and then the I bit from here, uy gradient of ux, and the I bit from here, uz, z of ux, and all of that is the I component. And then you do the y component. ux and all of that is the j component. And then you just write down all the k components. And all that is in the k direction, and this whole thing here in that component form is the total derivative. Thank you for watching. Bye.